Nou, bij Guix is binnen nog een keer
Okay, thank you all for coming to my talk. I'm Janneke, and the talk is about the reduced binary C bootstrap for Guix currently that I wrote. There's an overview. We'll get past half of this page probably. There's an introduction about what's a binary C bootstrap, why we would want to do it, how we did it at a high level, and what's in the future. So it's the talk starts with GNU. So GNU is a scheme interpreter, a tiny language written in the simple form of C, and a C compiler written in a pretty simple format of a scheme. And it's called mass because our scheme is built on level and apply, which are sometimes referred to as the Maxwell equations of software. Okay, so what's a compiler? The command that you see at the top is GCC. That's a C compiler, and the compiler produces a program that you can use run on your computer from human reading code. So this is a program that humans are supposed to be able to read, and GCC will convert that to a program that is still readable for humans, but it's harder and it's harder to program in. And then it doesn't have to be this way, but often it's a two-stage process. So then the assembler produces object code, which looks like this. The computer can read that, and then you need some stuff at the front to be able to execute it as a program. So obviously, you don't want to type in these codes when you want to have the computer greet you, say hello world. Okay, so we got compiler, we got NAS, we got compiler. So what's a binary C? Now, binary is a program that was not built from source, but you run it anyway. You want to run it. A binary can also be a program that you have the source code to, and you might be thinking that you're running the program from source, but actually it's a previous version, a previous generation of the program that you have the source code from. You're actually using a binary that was created earlier. That's a very popular thing to do. We do it with GCC. But mainly any language, even languages that are being created new today, like Perl 6, are written in the language itself. We may only hope that there's another way to create the first the Perl 6 compiler. So, a bootstrap C. If we look at Guix, the current version, 0.16, it uses 250 megabytes of opaque binaries that we use to build the whole software distribution. So that's a pretty small seed compared to the rest of the whole distribution, but it's still pretty large. If you look at more traditional distributions, you see a similar set, but it's almost like twice, 3 times larger even. And this is a trusted set of binaries that we are all taking for granted. And so what's a bootstrap? So a bootstrap, the straps, the things that you see here are the straps on a boot. And to bootstrap yourself is actually to pull yourselves up using your bootstraps. So traditionally it's an impossible task. So what does it mean to bootstrap in programming, say compiler or a kernel? You take the source for a program, you add something, and then you get the binary that you can run. And the thing is, this something. What do we do there? So we use an ancient recipe. So actually, you can think of the source code as you can think of the source code as milk, and you add a bit of yogurt, and you create more yogurt. So actually, all we have to do, if we want to create the next version of GCC, is just use GCC, and we're done. Okay, so what does it mean to reduce the binary seed of Bootstrap? Well, one of the biggest things in the Bootstrap is GCC and the tools it needs. So we simply replace GCC. This is the current reduced Bootstrap draft. We will use the upcoming version of Guix. And I won't go into details here, but here is the first version of GCC, version 295.3, which is actually built from source by this chain. And MES is one of the first binaries that we use. So MES, we had most of this. Let's see. Yeah, so the reduced binary seed Bootstrap, the thing that's new here, that it has the binary seed that we use to bootstrap these from 250 megabytes to about 130. So why would we want to do it? Well, almost at least 35 or 40 years ago, people realized that if you are using a binary that you cannot inspect, it's a trust issue. And Ken Thompson wrote a great speech, an article, a prototype of why you don't want to start with binary seed. You shouldn't do it if you care about security or privacy. Okay, let me go further. There are more people who advise against it. Why would we not use a binary seed? Well, we used to bootstrap our computers from source in the 70s, 60s. We used to do it like that. It's very pragmatic. If we don't use binary, well, if we want to support new hardware. Then I have kind of a joke. If you look at it, we'll go into that. So security expert Bruce Snyder remarked that the trust attack, as Ken Thompson described it, is not just an interesting anecdote, it's becoming more relevant today. And Peter Herman says something similar. He says enterprises overlook or bypass processes to ensure they can trust the software. And he even says you still cannot trust any software today. And David A. Wheeler, who got his PhD on diverse double compilation to address bootstrap binaries, thinks this is a good idea.
You mentioned the Thompson attack, but I feel like if I didn't know what a Thompson attack was, I wouldn't know from right here how you would do it to make it dangerous. Like what would somebody who was doing something malicious, what would they put in that binary?
Yeah, so the question is, how does a Thompson attack work? How could someone do something dangerous? Well, to go into technical details, I don't have the time, read it up. But the interesting thing is that if you use an untrusted compiler, and Ken Thompson showed it, actually you give out of hands all control of your computer. And it can, at any point in time, it could do anything the compromised compiler writer.
And they can put it into the next compiler too. That's a key part.
Right. Right. And it's very hard to find if you use the Ken Thompson attack. And James Comey, who was the former US FBI director, in an interview he said, well, it's just people ought to take responsibility for their computing. So people should put tape on their monitor, on their cameras and on their microphones. So paraphrasing him, he says, I can say the FBI thinks we shouldn't just trust binaries, we should use weapons. And Guix, who wrote the Rolling Software Distribution, says, well, the same. Big binary blocks of code are non-auditable, and using them is a hazard, and our goal is to reduce them to a bare minimum.
They did some research in the 70s regarding high-level language computers, where you actually don't need a compiler, but that they can directly run like a disk, or they can run C codes. But then that has been put aside because then compilers have so mature and so advanced. But if we look at the statement from the ABI, maybe then high-level language computing would become relevant again, because then you can bootstrap everything from source, because there is no concept compiling your code, right?
And it's a long remark. There's a remark question like, didn't we do much smarter things before, and maybe even in hardware have a high-level language? I think we're just reinventing the wheel over and over again, and let's talk about that. So the interesting thing is that the GPL version 3 allows you to distribute binaries. So the question is, can we distribute a GCC binary at all? And there are, well, you may be able to, you may be allowed to do that if GCC for -1, the one you compiled your program with, is a system library. I don't think so. Or if GCC -1 is a general purpose tool. Some people would say it is, but you also could argue it's a very specific tool. It's a C compiler. You cannot compile Python. It's not general purpose. But there's another exception, and that is you can, if GCC -1 is a generally available free program, and then lawyers can find out what program is. But I assume that it's about the binary, because I cannot run source code, right? So then maybe is it legal for Debian to distribute GCC in Scratch? Well, maybe if it was legal to distribute the GCC in Jessie, and you can see where that goes. Luckily or unluckily for some, the GPL version 2 is more lax than that, so why would we do this reduced binary C bootstrap? Well, for me it was also a big part of inspiration. I was inspired by this 500 byte hex 0 monitor written by Orange Chain. You just should have a look at it. It's really great. It's 500 bytes and it can just reproduce itself, but also create a more interesting program. So we might be able to bootstrap our system 500 bytes, and we can audit that. So, say we have GCC, which looks as yogurt. So how we remove the yogurt? Well, that's easy. We eat it, right? So GCC tastes like yogurt, but is it really yogurt? Well, So here's where we go from bootstrapping to bootstripping. It turns out that TinyCC developers put a lot of effort in making sure that TCC can compile GCC. And TCC is an order of magnitude smaller than GCC. But yeah, is TCC yogurt? It's still a big binary blob. So finally, there is MESS and the MESS C compiler, which is a really small binary blob, which can compile TCC. So the problem has gotten smaller. But I'm sad to say that MESS is still pretty problem. So here's how MESS-C works. MESS-C is just is a Steam script that could be run on Guile or on the MESS Steam interpreter, and it's a C compiler. It compiles a similar Hello World program to something that looks suspiciously like assembly, and that's actually all that MESS and MESS-C do for us. And then it will invoke a program from the stage 0 project from Orins J, of which X2 is the first program. There's a program called the M1 macro assembler. So this is M1 macro code, and it's assembled to this X2 code, and you can see that it's already pretty close to machine executable code. And then there's the linker stage, the X2 linker, also part of the stage 0 project, and we'll get our binary product. So this is how it works. But of course, our ultimate goal is, well, as I presented it 2 years ago at FOSDEM, when it was all a dream, is the full source bootstrap. We won't stop before we bootstrap our systems from nothing but source. So here a bit about the current stage of stage 0. So when I started 2 years ago, stage 0 was only an inspiration, but now over the past 2 years, MESS has been implemented, and I've been working very closely together with the stage 0 project. And this is the current state of stage 0 and how it comes together and comes towards MESS. So the lowest level, that has all been done. There's an Hex 0 monitor and an Hex assembler, which produce much more, just a little more capable Hex 1 assembler. And there's stage 1. The Hex assembler can create Hex 2 assembler, which can handle labels and do interesting things. And just recently, a C compiler for a very primitive form of C has been written in M1 macro. So we have bootstrap C compiler, which is, it's really a C subset, and it can produce compile M2 Planet, which is written in a simple version of C. Then you can see where this goes, because now here is MESS, which is currently it's a C program, but we're in the I've been working for weeks now to get the C program MESS translated into M2. It's just a lot of work, can be done, but we want to have a readable program because apart from having an all-source bootstrap path, one of the key things is that it's auditable and understandable. So the red things are the stuff that is missing. We cannot bootstrap MESS yet, so there's a gap. And there's a thing with the C library, which isn't there. But just imagine we have this done. Then after we have MESS, there's still a bigger C library we need for TinyCC. It has been done, but it's marked in red because it hasn't been translated to F2 yet. And we need a bigger C library to be able to compile the rest of GNU. And there's this thing with bootstrap binaries. There are different paths how we can do this. There are ideas to burn all this code in one big chain of commands in firmware, but we are prototyping it currently in Guix, which means you're running on a Linux kernel and you have to execute scripts. So in practice, we're looking at all kinds of binaries. The 130 megabytes that I showed you that we still have in the current reduced binary C bootstrap. So yeah, that's a question mark right there. And up from there, it's pretty much done. This is all scripted in Guix, ready to be merged in master. It works, and we have GCC 4.7 compiler, which builds the rest of the system. Yeah, so what's the next stage? I said we were aiming for the stars, but we do it in very modest, simple steps. So one of the things we're working on is, as I mentioned, the MES.C to F2 translation. But another exciting thing, I think, is the Guix project, which is a scheme implementation of all the utilities we need. You can think of it as BusyBox, but then written in scheme. So we can, if we run it on MES, you can see it as a source form of BusyBox that you can run. And that's work in progress. That's already on the way. And we, so the first step the next milestone will be the scheme-only bootstrap, which will hopefully reduce our 130 megabyte binary seed by half. We aim for 60 megabytes or so. And then reducing MES of M2, so reducing the MES binary seed will, well, hopefully bring us down another factor of 2. We'll see. Things that have been happening. I said Bash. Actually, there were 2 projects of implementing shell or bash in Scheme. There was a historical Bash project, and there was a Guix project by Timothy Sample, and the Bash project by Husband von Beusekel, and the project merged. So we are ready to go forward, and we hope for a 0.1 release the coming month or the coming months. Yeah, so that's where our focus is. So I didn't do this alone. I did a lot of programming alone, but I had a lot of giant shoulders to stand on, and I had a lot of help on IRC in real life by a lot of people, which I'm really grateful for. So thank you.
Jan, thank you. This is a massive project. I was wondering if people wanted to help, what would they have to do? I mean, are there any low-hanging fruit that you can work on? Or?
So there's a question, how could people help if they want to join in on this project? One of the first things is visit us, send us a mail, look at the website bootstrapable.org, or visit us on IRC on Bootstrapable, and just say hello. Just having support is already very important, because when I started this 2 years ago, there was a lot of discouragement going on. This is impossible to do. So it is possible, and support is very important. Well, there's all sorts of things that could be done. if you're a Guix developer or you want to become a Guix developer, you can help getting this reduced binary seed bootstrap into the mainline. There's an ARM port underway. This is for x86 32-bit only, although we do bootstrap 64 bits at the moment from it. So if you know ARM, please come and help. Yeah, there's lots of things. What we especially need is documentation and audit.
And busybox?
Yeah, Gash, we have our busybox in Scheme, if you like, hacking Scheme or learning Scheme. We have a simplistic implementation of awk and of set. We need more.
Why do you need ARM? As you add GCC, you have a first compiler, and so you don't need to do anything specific to ARM, right?
So the question is, why do we need ARM? Once we build GCC, we can cross-compile. That was discussed. It was an option, but if you're running ARM, you really don't want to depend on binary on stuff that was built on Intel or on Intel hardware. So I haven't talked about hardware, but the same story goes for hardware. So it's nicer if we.
Do you have funding? Do you have funding? So something like going to the EU and saying you have these bug bounties. We have a solution for all our systems being insecure.
So the question was whether we have funding. No, we don't have funding. Interestingly, I applied for funding yesterday, thanks to Piotr and to Eelco. But chances are we won't get it. So if you if you're sitting on a big bag of money or know how to get funding, but don't, I think this is a valid project, come visit us.
Have you tried the European Union grants? I think that it's maybe the right period of time when this can get grant for this because of security and privacy and other stuff.
Yeah, so the remark is, have you applied for grants with the EU? Because it should be possible with privacy and security. The grant I applied for yesterday is indirectly from the EU. I did apply for grants in a previous life working on Lilypond. I spent 3 months of my life on it. It has been wasted time until now, but if someone can help me with that, it would be much appreciated.
Maybe you should ask the FBI.
Well, they're watching, right?
So if you run this on a CPU that has a Linux instance running as a management engine anyway, I'm sorry to ask that way, but what's the point?
Okay, there's discouragement coming from the audience. They say, you're running a compromised computer anyway, so why go through all that effort? You're totally right. So I'm only doing this to raise awareness and to make sure that people who are great about hardware address that problem. I cannot do that.
Now the sort of project raises I'm not sure if I pronounce it correctly, this open source processor. So those are the solutions.
I hear that people are working on it.
I think it could be worth to what movement to Power 9.
Okay.
Since Power doesn't have a management engine.
Okay, so there's a suggestion to port MES to Power 9 because it doesn't have a management engine. If you know Power 9, please come and help port it. The ARM port is well underway. It took 2 days of effort to do 80% of the work. So it's very doable to start working on it.
Actually, I'm very good experience with IBM, and I think that if you ask them, they allocate some people to help you port it. Because 1 year ago, or 1 year and a half ago, some of IBM came to us to come back to the community, and they wanted to more to
or something.